In the last problem, we're given a couple of sides and we're asked to calculate the other side. And so we could use Pythagoras. Now in this problem, we've been given one angle and one side, and we've been asked to calculate the missing sides and the missing angles. So for this problem, we're going to need some more trigonometry rules. And this time it's going to be using your sine, your cosine, and your tangent rules. And so if you cast your mind back to school, you might remember that these were SOHCAHTOA was the rule that you used. And what those meant was that sine of an angle, let's call it theta, is equal to opposite over hypotenuse. Cos of an angle equals adjacent over hypotenuse. And tan of an angle is equal to opposite over adjacent. And so where these came from, let's just find those sides first. So the hypotenuse is the longest side, so it's what we called C when we're doing Pythagoras. But the hypotenuse is here. The opposite is opposite the angle, which is here. I might just use another color for these so that you can see them. And then the adjacent is the one that's next to the angle, but it's not the hypotenuse, so that's adjacent. So what the trig rules were about, what I've done here is I've drawn three triangles that all have the same angle. So they've all got an angle of 25 degrees, but they're different sizes. But for all that they're different sizes, the ratios of the sides will always be the same. So let's take sine, for example. The same would hold true if we did the other ones. But sine theta would just be opposite over hypotenuse. So we would have sine of 25 degrees is 0.933 over the hypotenuse 2.21. Now if we calculate what that is, and this is just approximate to three significant figures, I've done this, so our answer is going to be approximate. So this is me calculating the sides that are needed, but 0.933 divided by 2.21, that's 0.422. Now let's try one of the other triangles. So let's try the second triangle here. So we're going to do sine theta. So this is our angle here, is opposite over hypotenuse. So this will call this for triangle 1, T1. For triangle 2, that opposite hypotenuse is going to be 2.8 divided by 6.63. And so I just drew those triangles and measured the sides, or you could just draw those triangles and measure the sides with a ruler, and then just try this for yourself. You can choose any angle you want to use, but let's try this one. So again, it's opposite over hypotenuse, 2.8 over 6.63. Sorry, 2.8 divided by 6.63. And you can see you've got the same ratio, 0.422. For the third triangle, the sine of this angle here would just be opposite over hypotenuse. So it would be 5.13 divided by 12.14. And you can probably guess already what we're going to get, but 5.13 divided by 12.14 is equal to 0.423. It's a little bit different because I was rounding the numbers. If we'd done it exactly, we'd get the same result for all of these. So what we're saying is, if this angle is 25 degrees, it's always going to be the case that the opposite divided by the hypotenuse is going to be equal to this ratio. And the other ones, your CA and your TOA, so cos theta and tan theta, so cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. So if you were to take opposite over adjacent of this triangle with an angle of 25 degrees, it would be exactly the same as opposite over adjacent for this triangle, which has also got an angle of 25 degrees, and it would be exactly the same for this third triangle. And the cos rule, it just means that this adjacent divided by this hypotenuse, if that angle is 25, that ratio is always the same. And when you enter this in your calculator, so say you're doing, so if you want to know sine of 25, so you can put that straight into your calculator. It gives you the value. Is this 0.423? It's 0.423. Again, we didn't get exactly that ratio when we calculated it from these triangles because it didn't have exactly the right length of the sides. But when you put that in your calculator, it's just telling you what that ratio will be. So if you're putting in sine 25, it's telling you that the ratio of the opposite divided by the hypotenuse is going to be this ratio. And you can use that to figure out the lengths of the sides or angles within a triangle. So it basically comes down to similar triangles. These triangles are all similar. It's as if you just scaled them up. And therefore the ratio of the sides is always going to be the same. That's all sine, cos, and tan are. Okay, so let me just delete this. And then we'll use sine, cos, and tan to solve this problem. What we have is sine theta. So usually for angles you use the Greek letters. So we'll use theta as opposite over hypotenuse, and it's constant for any angle. Cos theta is equal to adjacent over hypotenuse, which will always be the same if theta for any angle theta. So for 30 degrees in a triangle, the adjacent over the hypotenuse for a right angled triangle will always be the same. And tan theta is equal to opposite over adjacent. And that's where you get this SOHCAHTOA. Now in these problems here, we're going to have to use trig, and it's asking us to find the size of the missing sides and the missing angles in these triangles. So usual first step is just do a sketch, ideally a scale drawing, so that you can check your answers are about right. But I'm not going to do that here, just save a bit of time. But you should. Okay, so we're going to have a look at this. We'll decide what we want to find first. So we're going to try and find the missing sides first, I reckon. Actually, I might just find the missing angle first because that's pretty quick and easy. So another rule you need to remember. That's a right angle. Right angle is 90 degrees. So that's going to be 90 degrees. And if we want to find, let's call this, often use large letters for your angles. So I'm going to call this angle A, say. What we do know is in the angles in a triangle always add up to 180 degrees. And so we can use that rule to find the missing angle. So A plus 36 plus 90 must be equal to 180. So therefore A plus 126 equals 180. So therefore A, take away 126 from both sides. Again, you don't have to write out all the lines, just write it out in case so everyone can follow. 126, minus 120 would be 60, so it's 54. 54 degrees. Let's just check that. So 90, I'll do this in green because it's just a check. So 90 plus 36 is 126 plus 54. 126, 130, 180, that's okay. Okay, so we've now got a missing angle. We could also have found that using the SOHCAHTOA rules, but it's a bit quicker doing it that way. Now we're going to have to find the other sides. So as was the case, just let me get rid of this 90, we know that that little symbol means 90 degrees. So as was the case with Pythagoras, we're going to have a look and identify our sides. So the side opposite the right angle, in Pythagoras we called that C, and trig we're going to call that, sorry, in sine, cos, and tan we're going to call that H for hypotenuse. So the hypotenuse is the longest side. This time we do have to be careful about the other side. So we've got this angle 36 degrees, and we want the adjacent side as this one here that's next to that, and then across the way from that, so heading across the way opposite from that angle is going to be O, opposite. Let's try and figure out what A is first. So we've been given hypotenuse, we want to calculate A, so we're going to have to use SOHCAHTOA. So we're just looking for the one that's got the letters in it that we're going to use. So it's Ka, so it's cos. Write out your formula. So cos theta is equal to adjacent over hypotenuse. Probably shouldn't have called that A because we're going to get it confused with the other A. So I'm just going to call that phi. And we'll just change that through here as well, just so we're not getting confused as we work through. Now we'll put in our values. So cos 36 degrees is equal to adjacent is what we're trying to figure out. We don't know that yet. Divided by the hypotenuse is 40 millimeters. Now we want to get A on its own. Let's swap sides first. A over 40 is equal to cos 36. Therefore, we'll just times both sides by 40 because we're dividing by 40 at the moment. So if we times both sides by 40, we won't change anything. Everything stays balanced. So A is equal to 40 times cos 36, which equals. Okay, so then we'll just stick that into the calc pad. So 40 times cos 36. Now, one thing you do have to be careful with is just make sure you're set to degrees. And here you'll see up here, I've got deg, rad. So the same thing on your calculator, there'll be somewhere where you can change between degrees, radians, and a few other angles options. Just make sure you've selected degrees for that, otherwise you'll get the wrong answer. And I've got an error. It wants me to put in some brackets. Sorry, I don't use this calc pad very often. So it's 32.36, three significant figures, 32.4 will do. So it's 32.4 millimeters. So now we've got A. So we still need to calculate O. 32.4 looks reasonable. So it's less than 40 millimeters, can't be more than 40 millimeters because that's your hypotenuse. So that answer looks reasonable. If you've got a scale drawing, you could do a quick check on that. So the next one we want to calculate this opposite side. So this time, actually, we could use the adjacent that we just calculated. So we could use TOA, tan. But it's better to use what numbers you've been given already, so that in case you've made a mistake calculating this value, you're still going to get the right answer for this question. And so that would be adjacent and hypotenuse. So opposite and hypotenuse. And so that's going to be sine. So this time, I'll just do it up here because I've got some space. So sine theta is equal to, so opposite over hypotenuse. So sine 36 degrees is equal to opposite over 40 millimeters. So therefore opposite times both, so I'm swapping both sides and timesing them by 40. Just taking a bit of a shortcut. So you times by 40 on both sides to get rid of that, divide by 40 and then swap sides to get what you want on the left hand side. Is going to be 40 sine 36 degrees. So 40 times sine 40 times sine 36 is 23.51 degrees. 23.51. I think it was millimeters we were working in. Yep. So 23.51, three significant figures, 23.5. So O equals 23.5 millimeters. So for A, excuse my spelling, so missing sides are 32.4 millimeters and 23.5 millimeters. Missing angle is 54 degrees. The second problem, let's just check that's sensible. So there's another one here. You can figure out that this angle here is 36 degrees. Now if that was 45 degrees, these two sides would be the same size. But because it's, let me just show you those. So these two sides would be the same size if that was 45 degrees. This is less than 45, so this side should be a bit smaller than that side, and that's what we've got here. So it looks like it's right, and if it was a scale diagram, you could draw that and check it. Okay, second problem. So I've already drawn it, but you guys would draw it first. And ideally you would draw a scale diagram. So again, we're finding the missing sides and the missing angle. We'll do the missing angle first. So we'll call this, again, I'll call this tan phi. Just mark on a right angle. Find the missing angle. Angles in a triangle add up to 180 degrees. So phi plus 18 plus 90 is equal to 180. So therefore, phi must be equal to 180 minus 108 equals 72 degrees. So that looks about right. Okay, now we're going to use sine, cos and tan to find the missing sides. So first thing, let's use the right pen. First thing, label our hypotenuse, it's opposite the right angle. And then we're using this 18 degrees, so this one here. So the adjacent side is this one, opposite side is that one. Let's figure out the hypotenuse first. And so we've got adjacent, we want hypotenuse, so it's AH, so it must be cos K. So cos 18 degrees is equal to adjacent over hypotenuse. Let's move this up. So cos 18 degrees is equal to 60 over hypotenuse. Now we want the hypotenuse, so we don't want it down there, we want it on the top, so we'll times by hypotenuse on both sides. So then we'll not swap sides yet, and so we know that h cos 18 degrees is equal to 60. And then we want the hypotenuse on its own, so we're going to divide by, sorry about that, I keep using the wrong pen, divide by cos 18 on this side, divide by cos 18 on this side, and so therefore those are going to cancel out, so you're going to get h is equal to 60 divided by cos 18. Okay, so stick that into the calc pad. So we've got 60 divided by cos 18. We check the calculators in degrees, it is. So it's going to be 63.1 to three significant figures. 63.1. So that is equal to 63.1 millimeters. So then we're on to this last side. So we want to calculate the opposite. We could use the hypotenuse that we just calculated, but that might be wrong if we've made a mistake, so it's better to use the value being given. And so we've got opposite and adjacent. So we want opposite, got adjacent, so that's TOA, and it's tan. So tan 18 degrees is equal to tan opposite over adjacent. Therefore tan 18 degrees is equal to opposite over 60 millimeters. Okay, just going to take a bit of a shortcut. So I'm just thinking I'm just going to times that by 60 to get rid of that on that side. So I have to do the same on this side. And then I'm going to get rid of that tan 18 once I've got the 60 across. So I'm going to divide by tan 18 on this side. So I need to do the same on this side. So you're going to end up with what am I doing here? Sorry, being a bit silly. So we're going to have opposite over 60, so just times by 60. And then you've got the opposite on its own, which is what we're trying to calculate. So times 60 times 60. So opposite is equal to 60 tan 18. Put that in the calculator, which I've closed down. Let's give it a minute to open up. So 60 times tan 18. I've just double checked that it's still in degrees. So it's going to be 19.5 millimeters. Looks about right. Right, the answer missing angle is 72 degrees. Missing sides are 63.1 millimeters and 19.5 millimeters. Now we could do a quick check here. We can just use Pythagoras to check our answers. So if this was Pythagoras, we'd have the opposite side was C, and then these would be A and B, say. And so we'd know that C squared equals A squared plus B squared. So C should be equal to the square root of A squared plus B squared. Now our A and B is our 60 and what we just calculated, that 19.5 millimeters. And so let's just chuck those in and we'll just check that we get the right answer for the hypotenuse, which should be 63.1 millimeters. So we're going to have square root of 19.5, squared plus, double check it, so that was 19.5, and the adjacent is 60 plus 60 squared equals 63.09. We've got 63.1, we've rounded to 3 significant figures, so it looks like that's correct. Let's minimize that. So pretty happy that this answer is probably right. Oops. Okay. We've just got one more type of example to go with these ones to find angles if you're given a couple of sides, and then we're done with trig.